Alright, let's look at the last topic of vectors, okay, which is equation for planes in space. Okay, a plane in space is determined by knowing a point on the plane and a vector that is perpendicular or normal to the plane. Okay, perpendicular is same meaning for normal. Okay, that means the same meaning of perpendicular and normal is same meaning. Okay, so we need to find an equation for a plane. Okay, and then we have to know the two things, which is a point and a vector. A point and a vector. Okay, to get an equation, we need to know the two things, which is a point and a vector. So I'm gonna explain based on from example 27. Okay, look at the question. Find an equation for the plane through the point A orthogonal to a vector n. Okay, orthogonal ni that means perpendicular to a vector n. Okay, the point yang dia dah bagi. Okay, and then vector pun dia dah bagi. Okay, so let's start with the 3 dimension. Okay, this is z axis, x axis, y axis. And then I'm gonna draw a plane. Okay, a plane at this region. Okay, let's say we have a point P naught here. Okay, and then from point P naught we have a vector. We call it as n, which is perpendicular to the P naught. Okay, and then for point P naught ni, okay, we have a position vector. We call it as R naught. Okay, let's say we have another point kat sini. Okay, we call it as P. Okay, so bila ada point P kat situ, then we have a position vector for point P, which is R. Okay, P naught ni, the value for P naught is x naught, y naught, z naught. So the value for P is x, y, z. Okay, the value for vector is n1, n2, n3. Okay, so by adding these two vectors, it will give us the vector here. Okay, which is R minus R naught. Okay, by adding these two vectors, by joining these two vectors, it will give us this vector. Okay, dekat sini. And then we call it as R minus R naught. It is equal P naught, vector P naught to P. Okay, vector P naught to P also. Okay, because we have a 2 point here, P naught to P. Okay, so that means n, vector n, is also perpendicular with the vector R minus R naught. Okay, vector R minus R naught. Ni kat sini adalah R minus R naught, vector R minus R naught. So vector n is also perpendicular with vector R minus R naught. And also is perpendicular with vector R minus R naught. So because they are perpendicular, okay, the dot product between the normal vector and the vector of R minus R naught is equal 0. Okay, sebabkan vector n perpendicular with vector R minus R naught, so the dot product between vector n and vector R minus R naught is equal 0. Okay, so value for n, we know that value for n is value for n is n1, n2, n3. Okay, and then value for r, okay, r is a position vector for P, so the value for r is x, y, z. And then for r naught, we know that r naught is the position vector for P naught, so the value for r naught is x naught, y naught, z naught. Okay, so this is from this equation. Okay, from this equation, we substitute this value into this equation. Okay, so n is n1, n2, n3 dot, okay, r is x, y, z, r minus r naught, okay, r minus r naught, r minus r naught, that means r is x, y, z, r naught is x naught, y naught, z naught, that means x minus x naught, x minus x naught. And then for y minus y naught, and then z minus z naught equal 0. Okay, and then you have to do a dot product concept. n1 times dengan value for x, n2 times dengan value for y, and 3 times dengan value for z. Okay, so n1, okay, times dengan x minus x naught plus n2 times dengan y minus y naught plus n3 times z minus z naught equal 0. So this is equation. This is the bukan equation. This is the general form to get an equation for the plane to the point A orthogonal that orthogonal to a vector n. Okay, this is general form that we have to use. Okay, so we know that kalau dalam soalan tu, example 27 tu, okay, point dia dah bagi A113. Okay, point dia dah bagi A is 1, 1, 3. And then vector n dia is 2, 5, 3. Okay, so we know that for point A ni adalah x naught, y naught, z naught, and then vector n is n1, n2, n3. Okay, so and then we substitute into this general form. Okay, n1 is 2, so 2 x minus x naught, x is variable dia, minus dengan x naught is 1, plus n2, n2 is 5, times dengan y minus y naught is 1, plus n3 is 3, times dengan z minus z naught. Okay, z naught is 3, so z minus 3 equal 0. And then expandkan dia, okay, darabkan dia, 2 times x, 2x, 2 times 1, negative 2, plus 5 times y, we get 5y, 5 times 1, negative 1, which is negative 5. Okay, plus 3 times z, we get 3z, 3 times negative 3, which is negative 9, equal 0. Okay, and then solve. Okay, negative 2 minus 5 minus 9. Okay, 2x plus 5y plus 3z. Okay, so second ni negative 2 minus 5 minus 9, you get negative 16 equal 0. And then negative 16, okay, bawa sebelah, dia akan jadi positive. So 2x plus 5y plus 3z is equal 16. This is the answer. Okay, boleh nampak tak? Okay, 2x plus 5y plus 3z equals 16. So, kalau tengok pada notes tu, okay, the last equation kat sini, n1x plus n2y plus n3z, it is equal n. So, this is the equation for general form yang tadi tu. Okay, n1x plus n2y plus n3z, it is equal n here. So we know that n1, n2, n3 is 2, 5, 3. It's a vector dia. Okay, vector dia ni. n1, n2, n3. 2, 5, 3. Okay. Ni faham tak? Punya general form. The last equation dia. Okay. Kalau tak faham, boleh tanya dalam WhatsApp.